fourth lecture on the topic of a fiber optical communication with the wave nature of a light. Now, this is one of the most important part of a light communication, in that part, how the light will be travel from one side to the other side with the help of optical communication. I will be explained in this slide. Look at this. Look at this. The light is an electromagnetic wave having very high oscillation frequency and very short wavelength. Because whenever we are talking about the optical communication, the signal will be sent in the form of a light from the source. I'm talking about the source, and that going to be destination. The difference between source and destination is that in source side we have used to convert an electrical signal into optical signal. But how we can convert electrical to optical signal? At that moment we should be use a perfect optical source, and that perfect optical source is basically used in optical communication is LEDs, light emitting diode, and the working principle of light emitting diode is electroluminescence. And other optical source we use a laser. So that is used to transfer the signal in electrical form to convert into optical signal, which is directly going with the help of fiber, and that fiber will be receive the signal in particular acceptance angle. And if the signal lies in between acceptance cone, the signal must travel from the one side to the other side. But the angle is greater than the acceptance angle. It means the signal will never be passed from one side to the other side. So at that moment, the signal is totally lost, and the source signal is totally lost duration of the transmission, and that kind of a losses is known as dispersion, and sometimes we call a intradiscipline dispersion, sometimes we call a ISI, intersymbol interference, sometimes we call a attenuation, and many other sources which can be introduced into an optical fiber. And at the same time, if the signal going to the acceptance angle with the wave nature of light, it is accepted by the destination end, and the destination end we use a photodetector to accept the signal, and the photodetector is one of the major source for detecting the light signal. And the another one is used PIN and APD photodetector to accepting the optical signal, which convert into an electrical form. So this is the basic nature of optical signal, to sending the information from one side and getting the information from the other side. But easy way to understand is that the signal is totally converted into the form of an electrical signal, because it is easy to understand and easy to capable to transfer from one side to other side. The other thing from the wave nature of light is that the light waves have much higher frequencies than radio waves. They both obey the same laws and share many characteristics, because whenever I'm talking about the radio waves and when I'm talking about the wavelength of the light waves, both are very different from each other. So at that moment, optical signal is playing a very pivotal role for the transmission of the information. At that time we use a bandwidth. The band of frequency is used 1510 nanometer to 1665 nanometer. Nowadays, this is the band of frequency we can be used, a band of wavelength we can be used for transferring the information in terms of the optical signals. Now, next part is going on that all electromagnetic waves have electrical and magnetic properties associated, so they can quickly, efficiently and effectively share the data. At that moment, you just understand the point is that you can just send electrical as well as magnetic waves simultaneously with the help of electromagnetic waves. In this movement, you can share both the signals simultaneously without any lag, without any delay in between of that communication mechanism. Now, the last but not the least, in free space, electromagnetic waves travel at the velocity of a 3 × 10⁸ approximate that. So if that moment you can be send a large amount of a data without any delay from source to destination. Now coming to the next slide, I will be explaining a little bit more. The wavelength of a light beam is given by lambda is equal to V upon F. This is the basic formula of this, the optical communication and the wavelength transmissions. Look at this. This one is the formula where the light beam is given to the wavelength. If that is to be understood, the V is beam velocity and F is the frequency, which can be represent a lambda, which shows that how effectively that light will be travel and that data will be sent with the help of this frequency. Now the frequency is determined by the emitting sources. Now we are talking about emitting sources. Again, the optical source is coming at the point. In this point, you just understand the point. They are an optical source. That is one of the most important part of a communication in optically. When the optical sources understand the frequency, understand the wavelength of the signal, it means you can easily share your information. The current, the voltage and the power all combined together, but it will be travel and transfer in terms of a light. And that movement of a light, you just know the wavelength of that light. It means you can share your voice, message, text, image, video, any kind of a signal with the help of optical sources. But before source sending, you just understand the wavelength of all signal. It may be text, it may be video, it may be message, it may be picture, it may be anything. Club together and send a combined wavelength together with the help of a source in terms of a light. Again, I'm talking about a light because all the signal, all the wavelength collecting together and share from the one side to the other side in the form of a light. Again, in the form of a light, traveling from one material to another material. Without any delay, without any lag, without any dispersion, we can share any amount of a data from one side to other side. So this is the beauty about the optical communication system where the communication is used with the help of a light. Now I will be explaining the next slide how that can be important for the communication purposes. First thing is that particle nature of a light. Sometimes light behaves as if it were made up of a very small particles called photons. The energy of a single photon is WP is equal to HF, and this is the basic amount of a light, basic fundamental amount of a light which can be used with the help of that optical communication. This is a single unit of a photon which is used to travel at the moment, and where H is a Planck constant and the value of a Planck constant is a 6.626 into 10 raised to power minus 34 joules per second and is called a Planck constant. Particle theory, the particle theory in optical communication explains generation of a light, how we can generate the light, how that generated light is to be traveled, and how that generated light is to be used into a different kind of optical sources, or it may be used into different kind of a communication purposes, communication module where the light will be passed from one side to the other side. Here, the such thing is LEDs. Now talking about the lasers, now laser diodes and many other sources which can be used to share your information in terms of a light. You always use this thing. If you are using such things, your amount of data will be very huge and very efficiently it will be passed from the one side to other side with the help of these optical sources. Particle theory also explains detection of a light. Whenever you send your signal in the form of a light, it is also important for the destination end. It is detected by the detector also. If the detector does not detect the light simultaneously, it means your signal will be totally lost. It means at detector point, you can use a photo detector. Look at this. Photo detector means it is detect the light. It comes from the source and with the help of optical fiber. If that understand the point, it means your signal is totally conversion of optical radiation to an electrical current without any lag, without any delay. But if optical detector is not detect the signal, it means it is losses somewhere in the optical fiber, or it may be a losses somewhere into a transmission medium. So at that time you used to check what kind of a fiber used for the communication purposes, single mode fiber or multi-mode fiber. That is depend upon the particle nature of the light. So that's why it is one of the most important part of optical communication. For the transmission purposes, you just understand how much light is to be detected from the source and how much light is to be forwarded to the detecting end, and how effectively the particle of a light is to be traveled in between the fibers. If that is going very efficiently and very effectively, it means it is plays a very pivotal role in the communication purposes to travel a large amount of data without any delay, without any lag, with the help of optical fibers. Now come to the next point about the optical communication. Is find the number of photons incident on a detector in 1 second. If the optical power is 1 micrometer and the wavelength is 1 kilometer, at that time you just understand how much amount of data is to be used in optical fiber, and optical power is used to travel that data. That is one of the major part in that thing. if the data is not effectively going on optical powers, it means it lost in between the optical fiber. So remember that point. The source play a very pivotal role. The signaling strength, Planck constant, optical particle, everything including the optical signal and the wavelength is placed very effectively and efficiently. If it is not placed effectively or efficiently into the network, definitely your data will be lost, because the network itself combined together lots of nodes and lots of communicating link. If are connecting together, then you must share your data. Now we are talking about some advantages of the fibers. Because nowadays we can use a two type of a mechanism for the transmission of data. One is guided and other one is unguided. If we are talking about guided media, in guided media we use a coaxial cable, fiber cable, optical fiber cable and many more things. At the same time, we are talking about which optical fiber is effectively used and how the data will be sent on that part, which is defined by the advantages of the fiber. The first advantage, the basic material used is a glass fiber as a silica, or it may be used as transparent plastic, both of which are plentiful and readily available. Because glass, silica, both are available is very efficiently and very effectively. You never think the data is going effectively or not. You just check the optical fiber is simultaneously transfer the data throughout the source to the destination without any lag, without any delay. So with the help of this means the optical signal, the signal which is to be traveling from the source to destination is in this fiber is going very efficiently or effectively. That is the part which is utilized by the sources. Now for the long path, if I am talking about the long path, we just go for such thing, because optical fiber is cheaper as compared to the other communication system, because other communication system use a large amount of complexity, large amount of sources, large amount of communication particles and so many things. When we are talking about so many things, it means use a number of sources, number of destination, number of a communication link, number of a medium, number of a mechanism, and at that moment you just understand how the fiber play a pivotal role. Once the communication system is to be installed, once you just install an optical fiber system, it means efficiently you share your data, efficiently use your data effectively without any delay. At that moment, the longer path fiber cables are cheaper as comparison to the other system, because the longer part used for the other system play a very huge amount of a data loss, and we don't want to lose the data during the transmission effectively and efficiently. So once the transmission is easily to install, the metal cables at fiber are smaller and lighter, and that thing is effectively used and utilized a longer time period of the communication. So one more important thing, any advantage of optical fibers, the fibers once installed, the installation cost is too high. I'm totally agree with this. This is not a very cheaper system, but once the optical system is to be installed, once the total optical system is installed, after the installation, you just think about it is going to be a longer period. It's going to be many years. You share your data very effectively and very efficiently without any lag and without any delay. At that moment, the fiber cables are very strong and flexible and can be wrapped around tight curves. Amount of data, huge amount of data, wrap up on that optical fibers and send simultaneously. Just one click at the one end and you get the maximum amount of data from the other end without any delay and without any lag. The data will never be lost. You think about it. This is one of the major advantage of the optical fiber communication. Once the data is to be shared and once the data is to be sent from the one side to the other side, the data is going very rapidly, very efficiently and very effectively without lag of data. One fiber cable developed for the telephone application has more than 4 times the data carrying capacity as compared to the twisted pair cable, and diameter is 30 times less. Once, if we are using a normal fiber cable, if we are using a normal cables which are twisted together, the capacity, the wavelength, the electricity, the current, the path will be loose somewhere. But that is the hair size of optical fiber we can be used for traveling the light signals, optical light signal. You just understand how much times it is less as comparison to the twisted pair, as comparison to the other telephone cables. How much thickness of that optical fiber, the basically a pin of that dias, the pin of a and pen, the amount, the tip of that pen is very lighter. The same light weight of an optical fiber will be installed during on the installation, and the your data is use amount of data is to travel on that fiber with the help of a line, and that is the basic advantage of the optical fiber for the transmission of a signal is very huge amount of with the help of this optical communication and optical fiber. So these are a few advantages of a optical fiber. I'm explaining some more advantages of the optical fiber also at here. In this optical fiber, no electrical current flow through the fiber. So no electrical isolation, low, any kind of electrical insulation will be introduced on that part. You just share your data without any interference with the electrical signal, without any interference to other electronic parts, without any interference to other electronic communication part. You just share your data in the form of a light. So in that moment, your data excellently rejection, radio frequency interference and electromagnetic interference. Both signal is to be lost, does not require any kind of interference on that transmission. We can directly share your data. It may be electromagnetic, it may be radio frequency signals. It means you can share direct optical signals without any losses, without any kind of a connectivity introduced in between the source and destination. Your signal is going very efficient and effectively. After that, we are talking about we can pack numerous fibers together in a cable to transmit many channels of information along a single path without any crosstalk. It means if we are connecting multiple wires, if we are connecting multiple cables, they are known to be crosstalk in between. But in telephone line, whenever the landline system is used, sometimes the wrong number is to be dialed and the wrong number is to be picked by some other person and crosstalk will be continuing. Two people are already talking and the third number is interconnected with that part. It means interconnectivity between the two major parts. It is a beauty in the optical communication. There is no crosstalk. Only a efficient data, only a efficient information will be travel without source to destination, without any lag, without any delay, without any signal loss. So this is a beauty about the optical communication. You share your data effectively and efficiently without any kind of losses in the communication. Now, optic coupling eliminates need for a common ground between a fire transmitter and receiver. We agree, we totally agree. Now the scenario is that the coupling eliminates the need for a common ground between a fiber transmitter and receiver. Are you getting my point? This thing, the need for a common ground between a fiber transmitter and receiver. Optical coupling eliminates all this thing. It does not require any such kind of thing which can be used to use a common ground, which can be used a same transmitter and receiver. No need for such thing. You just share your views, you just share your data and just think about the data is going very fast and very efficient with the help of this common communication systems. Now we are talking about the next part of the slides. The few more advantages of the optical fiber communication or optical fibers, how efficiently, how effectively this fiber will be play the important role on the communication. Now look at this. Fiber optical system can easily be computed in system originally designated for a wire transmission. Obviously, the optical fiber is once installed with the help of a wire and it will be installation cost is very high. But the duration of a transmission and when the duration of a transmission going up very large, the loss is approximate is negligible. Once the installation is complete, you can send huge amount of data, larger amount of data. At that moment, you think the optical fiber is not costly, but the cost is very, very cheap as comparison to other network system is to be connected on that part. So that is the understanding of optical communication is important for the people. Nowadays, optical communication are very, very important for the transmission of a data and transmission of the information in terms of a wavelength, and a huge amount of a data will be shared with the optical fibers, and with the help of this is play a very pivotal role for the transmission purposes. Now fiber optic systems can even be made invisible to a user. Definitely optical fiber is invisible, it is not visible to other person. If that person don't know, it is optical fiber is used for a user purposes. that optical fiber is used for a persons for the information sharing, they never find out such kind of a cable is going for to share the information. At that moment, the beauty about that optical system is that this is totally invisible to the source and the destination. That is not a none of a business to the other optical communication or other communication networks for the communication purposes. Now, glass fibers can withstand extreme temperature. Example, 800 Celsius leaves fiber unaffected. Definitely, if the temperature is too high, if we are talking about ourselves at a temperature of 50, 50, 60, 61, we are feeling very heat, we are feeling very tired, we are feeling very humid. But you think about at the 800 degrees Celsius, the wire is not to be worried about. The signal is never lost, the information is never lost. Information is going very effectively and efficiently and shared constantly without any lag, without any delay. At that time, security, safety, crosstalk is important as comparison to other point of view. Security play a very pivotal role. When source send any information, to the destination, this period of a transmission and this period of a receiving end always kept capable to understand the data will be very effectively used and utilized on that part, and understanding the things, how effectively, how efficiently the information is to be shared. So, security is one of the most important part in the optical communication. If your data is lost, you never trust your optical communication. Safety, if the data is not safe, if the information is not safe, if the network is not safe, you never will rely on the optical communication system. Crosstalk never be introduced into the system because the wires are independently connected to each other and simultaneously send the data from one side to the other side. They are never to be connected to each other. There are never a signal will be interchanged one side to the other side. They are never be interchange their trajectory from the source to the destination. So definitely these 3 points are very efficient, very effective, used in the advantage part of optical communication. So I'm talking about lots of things about that part. The main part of the optical communication is right now the application of an optical fiber optical communication. The first thing is that fiber trunk lines. What is the meaning of a trunk line? Trunk lines are these lines which can be communicated from the one side to the other side simultaneously, and two-way communication used into the trunk line. It means two nodes or multiple nodes are connecting with the help of a network. These are known as a trunk line. Look at this. These are the nodes. This is the network which are connecting to each other in this way. These are the trunk lines. Trunk lines. So it means it is connecting together, up, down, parallel, serial, communicating all the way together. So this network is an optical network which showing that the data will be shared effectively. At that time, one of the first installed system, fiber trunk line connected telephone office in Chicago. The first. I'm not talking about the present scenario. I'm talking about the starting of the optical communication, where it will start and how the data will be sent, how the data will be connected, how the information will be shared. It is firstly installed in Chicago for a telephone communication because they think the signal with the help of a trunk line sent from the one side to the other side are effective and efficient, so we can be share their information very effectively. So with the help of this, we can be sharing our information from one side to other side. Firstly, in Chicago with the help of telephone line. Second, the offices were spaced 1 and 2.4 kilometer apart, operating at the terminal 3 rate. Each of the 24 fibers in the cable had a capacity of carry 672 voice messages. The offices. Now I'm talking about office because office play a very pivotal role. The person never share information one to the other, but with the help of this, we can be communicate from the 1 to 2.4 kilometer apart directly without going anywhere. With the help of the operating T-rate, each of the 24 fibers are connected and establishing on that part. Your information is directly going on that part and share your views directly. After this is a voice message. I'm just talking about voice. I'm not talking about video. I'm not talking about pictures. I'm not talking about any other thing. Only voice messages. And these voice messages will be shared into a 2.4 kilometer. Firstly, after that, when the repeaters are introduced into the optical communication, the repeaters messages can be sent over thousands. Look at this, thousands of kilometers of fibers, because of a low attenuation separation between repeaters in the fiber can greater than in a coaxial cable. Definitely. Now the data will be going from not for a 2.4 kilometer. We can be send a data for 1,000 kilometers, maybe more than 1,000 kilometers, without any delay, without any lag, with the help of optical fibers. But at that time we used only a 2.4, now 1,000. We required our repeaters because the signal itself repeat from one side to the other side, but the signal is lagged during the transmission. Dispersion is occurred, attenuation is occurred, but when I am connected with the help of that repeater, the signal itself repeat after a certain kilometers, 100, 200 kilometers, your data will be repeated simultaneously and going to the longer, larger, 1,000 times of a kilometer with the help of these repeaters. On that time we use a link for the transmission. Now next, the savings in installation and maintenance cost can be considerably very large, but are feasible. Once the connection is to be established, once the cables are to be established, your data always be remarkably sent from the one side to other side without any lag, without any delay. So that is the beauty for the transmission of the signals. Now come to the next part of this thing. That is the advancement of the optical communication. We're showing that how the things covers the larger space. Look at this, 6,000 kilometers between east coast of the United States and Europe. Imagination, you just imagine. I'm talking about 6,000 kilometer transmission of a data. It is used with a TAT8 covers. That is a one type of a optical communication mechanism network which is used for the transmission of a data. So with the help of this, we can be sent 6,000 kilometers of a data without any lag and without any delay. Terabits of data you can send simultaneously, effectively, fraction of second. The data will be going to the eastern US to directly Europe without any lag. Now with repeater spacing of 50 kilometers, just over 100 repeaters are necessarily used. You can connect 100 repeaters after 50 kilometers and just saying your data will be sent effectively. No lag, no delay, no loss, no dispersion, no attenuation, nothing need to be introduced between the source and destination, and your data going a miles away with the fraction of a seconds. Now, two pair fibers operating 295.6 megabits per second. Look at this, megabits per second, and with spatial coding method providing a total capacity of 40,000 voice channels. Means 40,000 voice channel simultaneously send the data with the help of two fiber cables. If I'm talking about multiple fiber cables, your megabit, terabits of data, petabits of data will be travel without any lag, without any delay with the help of this thing. Think about it, the optical communication play a very pivotal role nowadays for the communication. For a large amount of data, you can share simultaneously. Any n amount of data will be sent at that moment. No need to worry about that thing. Your data is going very safely and effectively from the source to destination. So that's the beauty of optical communication. Nowadays, optical communication is important as comparison to other communication systems. Now, more advanced, if we are talking about more advanced systems, use lower loss fibers, optical amplifiers to reduce the need of repeaters. Obviously, day to day, everyone wants itself to improve, to share your information. So here, I'm not using a repeater, I'm using an amplifier. Now, we are using three different kinds of optical amplifier. One is semiconductor optical amplifier. Now we use a Raman optical amplifier. Now I'm using a ADF optical amplifier. These three amplifiers are used to amplify our signal from the source to destination without any lag, to share your information and going very very high amount of data. So at that moment, these repeaters are to be totally replaced with the help of an optical amplifier. That's why optical amplifiers are important as comparison to the repeaters, because repeater itself repeats the signal, not amplified, but optical amplifier is amplify the signal, and it amplifies the signal in large amount When amplifier signal is large amount, definitely your data is going very efficiently and effectively at that moment. You can think how much amount of data you want to travel. Optical amplifier just a click away, and the data and the network is access huge amount of a data without any delay and without any lag. So remember the point, this technology is send thousands kilometer of data from the one side to the other side without any delay. So these are the few things. Now this is a next topic which we will be explaining in the next lecture. So today's topic is completed at here, and Jai Hind.